Stop blaming your model. Here's the truth. Your algorithm might be fine, but the data you're feeding it is what's failing you. If your data has holes or weird spikes, your model isn't lying. It's just learning wrong stuff. By the end of this video, you'll get what bad data actually looks like, how missing values and outliers secretly ruin models, and how little cleaning can flip results overnight. Even if you're new to data science, you'll get this. Think of data like ingredients in a recipe. When you're baking a cake, if half your sugar is missing or someone threw in salt instead, the cake won't taste bad because the oven does not know what to do. It's bad because the ingredients were bad. Models are the same. Algorithms don't hallucinate, they learn from what you feed them. If the data is messy, the model will learn whatever from it. Here's a dataset with blanks, values that literally don't exist. These voids aren't empty, they're information that the model can't make sense out of. And here we have a value that's way outside normal range, which you can call an outlier. Outliers pull the model toward bad data if you ignore them and let them be part of the training data. Let's head over to VS Code and see this play out in our sample data. Here we've created a simple dataset with two columns, feature and target. The target column is clean and consistent, but in the feature column, I've intentionally introduced two problems. Some missing values using numpy.nan, not a number, and one extremely large number, which is our outlier and doesn't match the rest of the data. Let's run the code. Here you can clearly see the blank entries, those nan values. And notice how every feature value is small except for that outlier, the 1000. That one number is massively out of scale compared to the rest. To us, it looks suspicious, but to the model, it's just another data point and won't ignore it until we instruct the model to do so. Now let's see what happens if we just build a quick baseline model on this data. We're not going to clean or ignore any data yet. In this model, all we're doing is filling the missing values with zeros so the model can run. Then we train a simple linear regression model and check two things, the learned coefficient and the R-square score. The goal here is to see how the model behaves when the data is still messy. Let's run the code. Now looking at our output, the coefficient is about 0.006, which is almost zero. And the R-square score is basically zero as well. That tells us the model has learned almost nothing meaningful. It couldn't find a strong relationship between the feature and the target. And that's not because linear regression is bad. It's because the data we gave it was distorted. The missing values turned into artificial zeros, and that massive outlier pulled the model in the wrong direction. So the model isn't failing. It's just learning from bad inputs. Alright, instead of changing the model, let's fix the data. We're going to do two simple things. First, instead of replacing missing values with zero, we'll replace them with the median, which is a more realistic value. Second, we'll remove the extreme outliers using something called the interquartile range. This helps us keep values that are reasonable and filter out ones that are distorting the model. Same model, but with a cleaner data set. So first, we create a clean copy of the dataset so we don't modify the original. Then, instead of filling missing values with zero, we replace them with the median of the feature column, which keeps the distribution more realistic. Next, we calculate Q1 and Q3 and use the interquartile range to detect outliers. Any value that falls too far outside that normal range gets removed. After that, we rebuild our feature and target sets and train the exact same model again. Let's run the code. After cleaning the data by filling missing values with the median and removing outliers, the model now fits the trend much better. The coefficient jumped to 10 and the R-square score improved to 0.81, showing a strong linear relationship compared to before. In real machine learning projects, your dataset can have millions of rows. with thousands of missing values and weird anomalies. If you don't check those first, not even the best optimizer, scheduler, or architecture will fix it. Here's a rule worth taking to heart. Clean your data before you tune anything else. Because data quality isn't just a step, it is the more important step. When you fix missing values and tame outliers, your model stops learning incorrect patterns and starts learning the truth. This is why data engineering isn't optional. It's the foundation of every model that actually works. Not because it's trendy, but because good data produces good learning. If this changed how you view machine learning, that's the real takeaway. Thanks for watching. More like this soon.